Okay, so today we're going to do some more solving of equations, but this time we're going to be solving for all the solutions that are possible, as well as solving for those equations that give us multiple angles. So we're going to start by finding all of the solutions, and that's going to lead us into how we solve for multiple angles. So to solve for all of our solutions, we're going to start by finding the solutions that are indeed on the unit circle. And then we're going to use those coterminal angles to determine what all of them are going to be. So remember, we have to remember the period of sine and cosine, and that is 2 pi. So like for secant and cosecant, okay, they have that period of 2 pi. So we're going to add 2 pi in standing for how many times you want to go around the unit circle. And then tangent and cotangent, okay, their periods were pi. So instead of adding 2 pi in, we're going to add just pi in. Again, where in stands for how many times you're going around the unit circle. So here we're going to go about the same process that we do when we were originally solving. So we're going to add the 1 to the other side. And then we're going to divide by 2. Okay, so we get cosine of x is 1/2, and we say, okay, where on our unit circle does cosine equal 1/2? That's going to be the pi over 3 family. Okay, and it's positive, so it's going to be pi over 3 and 5 pi over 3. And then we're just going to take the period, which was 2 pi, and add it to both of these with the n at the end for how many times you're going around the unit circle. Okay, so pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n would be our solution if we were finding all of the solutions. Okay, let's try it again. Still looking for all of the solutions. So I'm going to add the 3 or add the 1 and divide by the 3. So I get tan squared of x equals 1/3. And then I'll take the square root of both sides. So that's tangent of x equals plus or minus the square root of 3 over 3. Remember here we're going to get 1 over the square root of 3, and we can't leave that, so we multiply the top and the bottom by the square root of 3. Okay, so we get the square root of 3 over 3. The plus and minus is in the front because when we take the square root of something, we get a positive and a negative value. So for tangent here, we would get all of the values on the unit circle. Okay, so all we're going to do is take the ones in the first and the second quadrant. So x equals pi over 6 and x equals 5 pi over 6. Okay, and then we're going to add the period of pi in to both of these. Now we do not need to add the other two because when you add pi to pi over 6, you get 7 pi over 6, okay, which is what the value is in the third quadrant. And if you add pi to 5 pi over 6, you get 11 pi over 6, which is what it is in the fourth quadrant. So we do not have to use all 4 values here because we cover it with the addition of pi in here. So please keep that in mind, okay? And for our last one, we've got cosine squared. For cosine squared of x equals 3. So I'm going to divide by the 4. So I get cosine squared of x equals 3 over 4. And then I'm going to take the square root of both sides. So I get cosine of x equals plus or minus the square root of 3 over 2. Okay, so again, we're getting all 4 values here on the unit circle because it's positive and negative. And the period of cosine is normally 2 pi. But if we are getting all 4 values on the unit circle, instead of adding 2 pi to this, we're only going to add pi because we want to hit all of those values without having to write them out 4 times. So x is going to be pi over 6 plus pi n, and x is going to be 5 pi over 6 plus pi n. And here, if we, by adding pi, we're going to cover all those values again on the unit circle like we needed to. Okay, normally we would use 2 pi for cosine, sine, cosecant, and secant, but because we got the positive and negatives, we're going to use the pi over n. Now this is going to lead us into how to solve for multiple angles on the unit circle. And what multiple angles means is that next to our theta or our x, we now have a number. Okay, it's either going to be a whole number, it's going to be a fraction. And really what it means is how many times you've gone around the unit circle. So what we're going to do is we're going to solve it just like we normally would. So I'm going to add the 1 and divide by the 2. So I get cosine of 3 theta equals 1/2. Okay, now normally we would say, okay, where does cosine equal 1/2? You're still going to do that. So cosine equals 1/2 for the pi over 3 family. Hold on. All right, sorry about that. I noticed on your notes it said 2 theta, so I just changed it. We're going to say, okay, where does cosine equal 1/2? And that's going to be that pi over 3 family. So I have 2 theta this time instead of just theta equals pi over 3. And I have another 2 theta where cosine is positive is 5 pi over 3. Okay, now when we're trying to figure out how many times it's going around the unit circle, okay, we're going to normally add our 2 pi. Now these are restricted to finding the values between 0 and 2 pi, as you see up in the directions there. Okay, so now we have a 2 theta. So to get theta by itself, we've got to divide everything by 2. So we're going to divide everything by 2. Okay, so then we're going to get theta equals pi over 6 plus pi. Okay, and we're going to keep doing this process until we see all of the values between 0 and 2 pi. So pi over 6 would be our first one. Then we're going to take pi over 6 and we're going to add pi. So if you need to do that on another side, I'm going to do it right underneath here. Okay, where it means we're going to take pi over 6. We're going to add pi, which pi in a base of 6 is 6 pi over 6. Okay, so we're going to get 7 pi over 6. So our second value would be 7 pi over 6. And then we're going to take it again. We're going to add to our new value, which is 7 pi over 6. Another 6 pi over 6. Okay, so when we take 7 pi over 6 and we add 6 pi over 6, we get 13 pi over 6. Now remember, 2 pi would have been 12 pi over 6. So now we're greater than 12 pi, so we don't need that value. We found the 2 that go with that angle. So now we're going to do the second one over here. So we're going to divide everything by 2. So we get theta equals 5 pi over 6 plus pi. Okay, so 5 pi over 6 is going to be our first value. And then we're going to take 5 pi over 6 and we're going to add our 6 pi over 6. we're going to get 11 pi over 6. And then we're going to take 11 pi over 6 and add 6 pi over 6 just to double check that they are indeed greater. So we get 17 pi over 6, which is greater than 2 pi, so we don't need that value. We just need the 11 pi over 6. And there are our values. Now, when you are finding multiple angles of a whole number, you're just going to take the number of values that you normally get and multiply it by that number. Then you know how many values you should indeed have. So here we had 2 values that we got, and we were doing a double angle. So all we had to do was multiply the 2 by 4, so we should know we had 4 angles. So let's try this again. This time we have, we're multiplying by a 3. So tangent equals the square root of 3. So we're going to have 3x equals pi over 3. And 3x equals 5 pi over 3. Nope, 4 pi over 3, sorry. We need quadrant number 3 there. Okay, and now normally for tangent we add pi, so that's what we're going to do. We're going to add pi. And then we got to divide by the number that is there next to our x. So we're going to divide everything by 3. Okay, so over here we're going to get x equals pi over 9 plus pi over 3. So pi over 9 is going to be our first one. Okay, and then we're going to take those values. We're going to add pi over 3. Now, those do not have the same base, so I have to make them the same base. So pi over 3 with a base of 9 is going to be 3 pi over 9. So then here we're going to get 4 pi over 9, which is less than 2 pi. Remember, 2 pi would be 18 pi over 9. So I'm going to put 4 pi over 9 up here. And I'm going to keep going. So 4 pi over 9 plus 3 pi over 9 gives me 7 pi over 9. Okay, and I'm going to keep going again. So 7 pi over 9 plus 3 pi over 9 gives me 10 pi over 9. Okay, still less than 2 pi. So 10 pi over 9 is going to go up here. Okay, I'm going to do again. 10 pi over 9 plus 3 pi over 9 gives me 13, equals 13 pi over 9. Okay, and notice that in the tops there, we just keep adding 3, so I'm going to add another 3 there to the top, so it's going to be 16 pi over 9. If I add one more 3, I'd be at 19 pi over 9, which is too much. Okay, so I found all the solutions there for that piece. Let me go check out the piece over here on the right. So if I divide everything by 3 here, I'm going to get x equals 4 pi over 9 plus pi over 3. Now notice 4 pi over 9 was already one of our solutions. So we actually already took into account all the solutions we were going to get on that side. So we don't have to continue solving that because the values are already there. Okay, so we found all of our values. And to double check ourselves, right, we had 2 values to begin with. And we multiply 2 times 3, we should get 6. So we have 1, 2, 3, 4, 5, 6 values. We have done it correctly for our multiple angle there. The last example we're going to talk about is going to be what happens when they give us a fraction instead of multiplying. Pretty much every time you get a fraction, the value of the solution you're going to find is going to be 1. So let's check this out again. We'd solve it just the same way. We divide by the 2, so we get cosecant of x over 3 equals 4 divided by 2, which is 2. So in my head, I'm really thinking sine of x over 3 equals 1/2. And sine is 1/2 for the pi over 6 family, so I'm going to have x over 3 equals pi over 6, and x over 3 equals 5 pi over 6, because that's both where sine is positive. And this is sine, so I'd be adding 2 pi to both sides. Now, to get rid of a fraction, we'd multiply both sides by 3. Okay, so for our first group there, we would have gotten x to equal 3 pi over 6, which is just pi over 2, plus a 6 pi. Now, if we're adding 6 pi, right, to get us around the rotation, we're definitely going to be bigger than 2 pi. So we know that pi over 2 there is going to be our only solution from that side. Okay, so let's check out what's happening here on the second one. So we go to the second one, x is going to be 15 pi over 6, or which would give us 15 pi over 6, which would simplify to 5 pi over 2, again, plus 6 pi. Now, 5 pi over 2 is bigger than 4 pi over 2, which is 2 pi, so therefore this solution is not a valid one, so we only have one solution here, which is pi over 2. So if you have any more questions about this, please come see me in class, and we can work on it before your test.